Hello, today we're talking about 3D rendering. And I know that this is about drawing, but I believe that it's very important to know about 3D rendering because it is the basis of our modern understanding of how light interacts with objects and how we see. So basically, what 3D rendering is a simulation, and it describes how light interacts with things and goes to the viewer. So light can do three things. Let's call this arrow light, and this is our object. Light can either be absorbed, where it doesn't do anything. It can be transmitted, so it goes right through. Or light can be reflected off our object. So a lot of what 3D rendering is about is generally about light reflecting off of an object. So we have a light source here, and we have a reflection here, and this is us seeing it. So we all sort of understand what these things, like a clear glass is transparent, so most of the light goes through it. With some sort of exception, it's actually refracted, so light doesn't actually travel straight through. It ends up coming out at a different angle. Alright, so, some dots. If light is only reflected, how are we able to see an object? Like if I have a light source behind an object there, why am I able to see this ball in general? Like, I'm in a room, I have a light from the ceiling, why can I see this? So what happens is light is actually coming from a variety of directions, and that is because our main light source, which is the sun, hits something like a tree, and some of that light is reflected back onto our ball, which we then see, right? So 3D rendering kind of takes into account all of those things. So when we have a light source hitting our object and we see things like the back of it, that is because of atmospheric light. So that's light bouncing off, basically off of a room. So we have our light source hitting this, it kind of reflects off here, and then back, and then that way. And the main thing I want to get across is that I'm talking about a reflection. So a reflection, if we have a single beam of light reflecting off an object, this angle and this angle are going to be the same. So again, if I only have this one light source, coming from there, why I should only be able to see the light source from this angle. Because if I look at this spot, there's no light source from over here. And if I look at this spot over here, again, there's no light source because there's nothing to reflect off of it. So, again, we see it because of atmospheric light. But surfaces of objects are also are not like a perfect mirror. We kind of know this, obviously. We can see like a flat surface, like the surface of a table. But if we look closer at the microscopic level, what we actually will have is kind of a random assortment of surfaces. Each of these surfaces will act as a reflector, so each one will kind of reflect off. So if I only have light from this direction, some of it will be reflected off that way, some of it will be reflected off that way, some of it will be reflected off here, and then you kind of have corners where it gets trapped and reflects in all sorts of directions. But like this scale is very small. It's usually not visible with the naked eye. You could see maybe a microscope or a electron microscope or some such. Right. I feel like I'm moving far too quickly. But whatever. Right. So the next thing I want to talk about is intensity of light. What we sort of see as brightness, we think that we have one ray of light, and this is either bright, let's call it a brightness of 10, or it's very dim, a brightness of 1. In actuality, the intensity of light is determined by flux. A single beam of light only has one energy. It's 1. So if we have 2 or 3 and they're very close together, they will look fairly bright. But if we have 3 spaced far away from each other, this will appear dim, right? And that's referred to as flux. So it's basically the density of light beams is flux. So this would sort of represent an intense beam of light, whereas this would represent a less intense light source. So why I'm talking about that is because of reflections. If I have a board, my prototypical board, and I'm looking at it over here, and I have light kind of reflecting off this way to my eye, it will be of a certain intensity. But what I mentioned before with the surfaces is that it will appear that a light beam coming incident on the surface will appear to be diffused in all directions. It's going to be scattered. And that is because of that microsurface where that is. So this is actually like 10 tiny beams of light being scattered randomly in all directions. So a very simple 3D renderer will account for that diffuse lighting. So if I have light coming off from this angle, I am going to have this coming off here, whatever, and at any angle that I look at this at, it's going to appear about the same intensity. So the brightness of the surface is only dependent on the angle. So a high angle, meaning something like this, where that's closer to 90, will look brighter. And the reason for that is because of your flux. So if I have all those beams, they will scatter kind of equally, and the intensity will be based on this flux. But if I have a high angle with the same intensity of light, the resulting light will be of less, will have a lower flux. It'll be less intense because this will kind of reflect off that way, that'll reflect off that way. So we'll have a lower intensity. So basically, what all this comes down to is, if I have a surface and I have a light source coming from this way, this surface will look brighter than a surface with an equal intensity light coming off it that way. So that was basically the point of everything up to now. And computers generate these images based on the incident light, based on that angle and the intensity of the light. So they also do other things. They account for an atmospheric light, which can kind of lower and raise the intensity. But up to this point, I've only been talking about the intensity of light. So what about the color? Well, the color of objects is because objects and matter will absorb, transmit, and reflect light depending on the wavelength. So a red beam of light on a particular object may be reflected, but a blue light, this object may be transparent to the blue, and it may absorb green light, so green light doesn't come through at all. So if I look at this object from this side, it'll appear red, even though like a white light is shining on it. I will see a red object. If I look at it from this way, I will see a blue object because blue is being transmitted through it. So, needless to say, different materials have different color altering properties. And you know what? That sort of sums up a very basic scheme of what a 3D renderer does. It will take an object and and a light source, and it will calculate the intensity and color of light off of the visible directions, right? So I'll look at it from this scene, sort of, and it will calculate the intensity of light at each point on the surface. And that is sort of what we do when we draw something. It's exactly what we do. We draw an outline of an object and kind of use our educated guesses to determine that this area will reflect less light than this little spot. And because of the atmospheric lighting, this part of the sphere will not be in total blackness, but the spot below it will have this area blocked out from the light. So it will only have the colors and image that you see from this spot will only be determined by the atmospheric sort of uniform-ish light. Right. So that is a very quick and very crash course on rendering. Computers do this in fairly quickly, but that doesn't mean that you can't use that process to make better drawings. It actually gives you a rigorous sort of list of things to do when you draw. The first sort of thing is kind of place the objects, right? Draw an outline. The second sort of thing to do is determine where is the light. Where is that coming from? Third sort of thing to do is sort of in conjunction with two is how is the light blocked? So where are the shadows, right? And then the last and most complicated step, once you have that, is to determine your rendering, right? To determine the intensity of light at different spots. So in essence, that is just the shading, right? And you can do that in a number of different ways. But if you study three-dimensional rendering, you can actually you can use that system to make drawings by hand. You don't need a computer. You just need something to draw on and something to draw with and an idea. It doesn't even need to be based on an existing object. It can be something from your brain. Right. I think I feel like I just rushed through that, so I'm not entirely happy with this. But I went 5 minutes longer than I wanted to.